Hey friends, Dr. Borole is here. Today we are going to discuss the last part of this unit, digital computers, in which we will see the microprocessors and microcomputers. The digital computers are classified under three groups: microcomputers, mini computers, and maxi computers. Those are called mainframe computers. The basic block diagram of a digital computer is shown here. Let us focus on the figure shown. It is basically a digital electronic circuit with lot many advanced features. It consists of a basic central block called CPU, that is called central processing unit. It is implemented using microprocessor. The CPU performs lot many tasks that we will see next. For performing the operation by CPU, it will be under the control of the user program. So CPU have capability to understand the user instructions. Those are given in the form of digital inputs. Those digital inputs called instructions, those are stored in the memory, and central processing unit is having capability to read these instructions sequentially one after another and execute these instructions. Instructions are nothing but the digital code combinations, and every code have unique meaning to the central processing unit. When processor get that digital input, it will behave in a predefined manner. So therefore, one block that is essential with a digital computer is a memory device. The memory device is classified under two broad categories. Those are called as read-only memories and read-write memories. Read-only memories can also be called as RAM. That is the another name for read-write memory, which is loosely used in practice. This memory is readable as well as writable, and it is having random access for its storage data. Means inside the memory, if there are thousands of instruction bytes present, then this memory is capable of accessing any byte at any time randomly. There is no need to read the bytes one after another. The memory is capable of supplying the stored data when the address is placed on the address pins of the memory. And address can be changed to any location address. The memory is capable of supplying that data instantly. And this is called random access. So memory is required to store the user programs as well as the system programs required to operate the computer system. Whereas the another type of memory that is called as read-only memory, that is also called as ROM. ROM is also having random access, but this memory is read-only. This memory can be programmed by the manufacturer. There are various categories of ROMs available. To start with, we can say that the ROM can be only read-only because the manufacturer has placed the operating programs for the system, and that is fixed by the manufacturer, and that will provide the basic operations of the system, and that program is capable of loading the user programs from the memories, and that can be executed by the central processing unit, which is implemented using single chip or multi-chip microprocessor systems. Another block is there. Since it is a sequential digital electronic circuit, all the operations performed by the microprocessor in a predetermined sequence. And for that purpose, there is a sequencing source. That sequencing source is basically a clock circuit. So clock will be providing very stable clock to the CPU so that the operations, the processor, central processing unit that can perform are sequenced in reference to the leading and trailing edges of the clock. So very important part of the microprocessor system is the clock source, and that is basically a heartbeat of the microprocessor system or computer system. If any time the clock will stop, the microprocessor system becomes a stone, and therefore it is the pulse of the microprocessor, that is a clock. The microprocessor system not only requires the user program to be executed, sometimes there is a facility required to enter the user program in the system or to give the inputs to the system. These are the digital inputs, and therefore the majority of the input devices are the switching devices. Typical inputs are coming from keyboard, and therefore central processing unit working on these inputs coming from a basic building block of digital computer system that is called as input port. This input port basically consists of an encoder, and inputs, those are digital inputs or on-off type of inputs. Those can be supplied to these input ports, via which this input can be reaches to the central processing unit. Those can change the course of execution of the program supplied by user. A typical example of input devices, those are keyboards, mouse, the stylus, and so on. The central processing unit executes the user program, also accept the inputs and generates some outputs. Those intended output generated by the central processing unit via program can be displayed or shown to the external world by using output device. Output device is mostly a decoder circuit which can decode the generated outputs and convert it to a displayable format or presentable format to the external world. The very common output device is a display monitor on which you can get the visual information of the output generated by the central processing unit by execution of the programs. Another output device can be a hard copy printer. There are many other output devices are also possible. So this is in short the block diagram of a digital computer. We will see a more detailed construction of digital computer architecture in the next topic. So here we have just seen the overview. Let us see more detailed architecture of a microcomputer system. This is the very important figure that is to be focused in your exams also, because only block diagram is mentioned in your syllabus, and that is nothing but the architecture of microcomputer system. So therefore, if there is a question, draw the architecture of microcomputer system, then you have to draw this figure and explain. That is a general purpose microprocessor system block diagram. So as usual, what we have discussed, the general purpose microprocessor system consists of a central processing unit, which is implemented using general purpose microprocessors. Microprocessors are the digital electronic circuit or chips, which have lot many facilities, those we will see later. So it consists of a memory, as we have discussed. Memory will be shown by the block here, RAM and ROM. RAM is basically a random access read-write memory, and a ROM is basically a random access read-only memory. The programs are mostly stored in ROM. Even user programs are also stored in the ROM, whereas the microprocessor can execute the program only from RAM, and therefore the programs which are available in the ROM or in the secondary memory like hard disk, those are first brought to RAM, read write memory, and then the execution is done by using the microprocessor or central processing system. So therefore, the memory most important is read write memory and read only memory. Read only memory is also loosely called as program memory, and read write memory, that is RAM, is also called as data memory. Again, we have discussed that to provide the external inputs to the central processing unit or computer system, we need to connect the external device to these systems like keyboards, mouse, or digital tapes, or any other sensors even. For that purpose, you need a port called as IO port, input and output port. Input ports are basically the ports via which you can connect the external input devices to the microprocessor or central processing unit. They provides the data from the external device to the microprocessor. Whereas output ports are the ports which can send the data to the external world, which is generated by the microprocessor system or CPU. So IO ports, input and output ports, are separately available in the system, and multiple input and output ports are available in the system. It depends on the system. These IO ports in general, what you are using in day-to-day life. For example, USB port is a IO port. Printer port is a input-output port, right? Whereas VGA port is a display port, that is basically an output port that is sending the data out. Whereas keyboard input port is basically the input port. And for that purpose, appropriate internal electronic, digital electronic circuit is present with the central processing unit system, that is called IO ports. The microcomputer system also have the additional block that can be called timers. Timers are optional, but they are also present in most of the computer system, so that the digital or time counting can be done and time keeping can be provided by using the timer blocks. Timers are basically the counters, and clock is connected to these counters to count the standard clock. So timers are basically time the operation, specific operations required under the program control. And these are the hardwares available. Timers can be a small 16-bit timer or 32-bit timers, or it can be a real-time clock itself, so that you can set any time of a day and you can trigger the event when that time reaches. So such type of thing can be done by the timer hardware, and which is programmable under the user program, which is executed by the microprocessor system or central processing system. The additional input output block that is used for communication is serial communication port. In this serial communication port, the data generated by the microprocessor system can be sent serially one bit at a time over the single line. I/O ports are basically sending the data parallelly, and therefore I/O port in general are dedicated to parallel operations. Means multiple lines at a time 8-bit or 16-bit data can be sent out. Whereas serial ports are also I/O port, but they can send and receive the data one bit at a time over the single line. So beauty of the serial port is it reduces the hardware. Parallel I/O ports needs multiple lines. Say for example, the 8-bit I/O port needs 8 lines to connect the external devices, and therefore hardware will increase. Whereas in serial ports, single line is used to send the data, and therefore 8 lines are reduced to single line. But obviously, whenever you have an advantage of serial communication or serial ports, you have disadvantage also. Parallel transmission through I/O ports is faster because it will send 8-bit data or 16-bit data or 32-bit data at the same instance, whereas serial port needs multiple number of clock cycles to send the same data. For example, if you want to send the serial data of 16-bit on serial port, it needs at least 16 clock cycles. So the operation of sending the data is 16 times slower than the data rate available with I/O ports. So this is in general the block diagram and the functions of the microcomputer system. The microcomputer central processing unit is connected to RAM and ROM and I/O ports and timers and serial communication port via various electrical connections. These various blocks like RAM, ROM, I/O port, timers and serial ports are also called as system peripherals. So the system peripherals are connected by the copper electrical connections with various wires. Those are called as buses. So microprocessor central processing unit have three type of buses: address bus, data bus and control bus. Address bus is used to connect the address information to all these peripherals. Address information is a digital information, but this information on these electrical wires is treated as address of a location in RAM, ROM or IO port or in timers. Whereas another set of parallel electrical connection, those are coming from these peripherals, are called data bus. Data bus also have a digital data on it, and it carries this data from RAM, ROM to the central processing unit and vice versa. So data bus is dedicated to handling the data. Address bus is dedicated to handling the address information. And the control bus, which is not shown in this diagram, is also going to each of these block. And this control bus consists of a typical signal, say read, write, and enable signals for various blocks. These signals are appropriately generated by the central processing unit whenever it sends the address and get the data from the system or send the data to the system ports. Okay. Now let us see in detail what is inside the central processing unit or general purpose microprocessor. We are going one by one inside the blocks of the microcomputer system. Main important block is CPU, and CPU is normally implemented by single chip microprocessor or multi-chip system of processors. Let us see what is inside. Externally, we have seen that it consists of and controls the address bus and data bus connections. So these external buses are available as terminal pins on the CPU. It also provides the connectivity for control bus signals as the pins on the processor. There are pins available to connect the clock crystal or clock input to the processor. And there are other inputs present. Those are at this juncture not important for us. These external buses are further connected to internal buses via the buffer circuit. Buffer circuit are also called as bus buffers, and these are basically the tri-state buffers. Those increases the current capacity of the internal bus whenever it sends the data to the external terminal address bus and data buses. Bus is basically a set of wires. For example, 8 wires carrying 8-bit data is called as 8-bit data bus. If these 8 wires are carrying the information, those are represented address of a particular location of internal or external location, then it is called as address bus. These are basically, bus is basically a set of interconnecting wires. Okay, so accordingly, we will have in the microprocessor or central processing unit, the external buses are connected to internal buses via bus buffers. Very important section shown here is arithmetic logic unit. So central processing unit have a arithmetic and logic unit, and most of the time it is basically adders and subtractor circuits with multiple bits input and generate multiple bit output. For example, if your processor is of 8 bit, its arithmetic and logic unit can generate the operation at a time on 8 bit, means it can provide 8 bit addition and subtraction. Some processor can perform the multiplication and division on 8 bit numbers. Current generation processor have 64 bit of arithmetic and logic units, that is possible, and higher size of arithmetic and logic units are also present in the current generation processor systems. So they are basically performing the arithmetic operations. For the arithmetic operation to be performed on any of the data, at least two operands are required, or two operands, those are required for the arithmetic operation. Those are stored in a temporary registers. Those holds your operand. So here register indicate a temporary register which is implemented by using flip-flops, data flip-flops. For example, 8-bit register is basically connection of 8 parallel D flip-flops. And these are addressable flip-flops so that microprocessor system can control the input and output to these flip-flops. So whatever the operation to be performed given in the user instruction can be stored in these temporary registers. They supplies the input to arithmetic and logic unit called ALU. And ALU performs the operation mentioned in the program under the control of timing and control unit, which is in turn synchronized with the stable clock. So, after arithmetic and logic unit generates that operation, the status of the operation can be stored in one of the data register called as status register. It is a register. It consists of multiple flip-flop again connected in parallel. For example, if you have a addition operation, so addition may results a carry generation. So in status register, there is one flip-flop available called carry flip-flop. Similarly, if the operation generates the zero result, then there is a flip-flop available which can be set and indicates the status of previous operation, that is zero. That is zero flag. The registers which holds the status in the flip-flops called as flags. So status register consists of various flags in the system. In addition to arithmetic logic unit, the microprocessor have inbuilt set of scratchpad register. Scratchpad registers are the registers in which data can be temporarily stored. Depending on the processors, the scratchpad registers can be from 6 or 8 to tens or hundreds of the registers available inside. These registers are decided by the size of the processor. For example, if the data bus size of the processor is 8-bit, normally the scratchpad registers are of 8-bit size so that they can store the temporary data which can be stored during the operation of the microprocessor. Similarly, very important unit available inside the microprocessor, that is the third part of the microprocessor system or central processing system, which gives the power to this processor to control its operation under the control of user program. So programmability is implemented using in the processor by using a special building block called as instruction decoding block. There are two blocks in this. The instruction register. This register holds the operation code which is received from the external memory is stored in the instruction register. This instruction register data is given to instruction decoder circuit, which decodes the code in this instruction register and generates the decoded output. Those are connected to timing and control unit, and timing and control unit then perform the sequence of operation by the control signal generated by the decoder. And this way, the processor executes the instruction. So, three major sections, or say rather four major sections in the central processing units are arithmetic and logic unit, then scratchpad register, then instruction register and instruction decoder, and timing and control unit. In the cooperation of these all blocks by timing and control unit, the user programs are executed from memory, one instruction at a time. Now, typical microprocessors, those can be used as central processing units, are classified as 8-bit processor, 16-bit processor, 32-bit processor, 64-bit processor, and 128-bit processor. The current generation processors are mostly 128-bit in size. It means the current generation processor can handle the data 128-bit at a time. A typical example of a microprocessor is from Intel 8085, Zilog 80, Intel 8086, which is a 16-bit processor, Intel 8088, which is the extended version of 8086, which was used in IBM PC first. The Intel processor series called x86 series, 80186, 286, 386, 486, and Pentium. These are the extended versions of 8086 with lot many feature on the chip. Those are developed by Intel. The Motorola is also a big company which can manufacture lot many other peripherals and general purpose microprocessor like 6800 series processor and 68000 series processor and Power PC series processor. Currently, these companies are manufacturing lot many new generations wide range of processors. The next topic is microcontroller. Basically, there is a slight difference between general purpose microprocessor and microcontroller. Microcontrollers are basically the central processing unit with built-in peripheral on the chip. So we have seen in general purpose block diagram of the computer in which there is a central processing unit. There are RAM, ROM, timers, IO ports, various buses and serial ports and so on. Whereas in general purpose microcomputer system, these peripherals are externally connected and implemented. So, general purpose microprocessor doesn't have support for these peripheral devices on chip. They are having facility to connect these peripherals via the interface of address data bus and control bus pins available. Whereas the microcontrollers are basically developed for a small systems or control systems in which the product can implement and needs the computer power with the built-in RAM and ROM facilities, which is smaller compared to the need of general purpose computer system. And therefore, the manufacturer have provided the solution. They manufacture the central processing unit with peripheral devices like RAM, ROM, IO ports, timers, and bus interfaces if required, serial ports, the built-in clock generator circuit on the same chip with the central processing unit. And this central processing unit is connected to these peripherals via internal buses. They can send the data to the external world via IO ports. Or they can even send and receive the data serially over the single lines. Microcontrollers are having lot of local power, whereas general purpose microprocessor have immense amount of power to handle the operations, but it needs the external hardware. And therefore, for smaller systems, microcontrollers are the good choice. If you see the block diagram in which you will see the central processing unit, what the function central processing unit performs, that is same in both microprocessor and microcontroller. The central processing unit consists of arithmetic and logic unit to support the arithmetic and logic set of instructions. Second, it will provide the internal scratchpad registers to store the intermediate data. Whereas normally the scratchpad registers in microcontrollers are much more than the general purpose processor. The third part the central processing unit have is the instruction register and instruction decoder that provides the power to this central processing unit to execute the instruction in the form of program provided by the user. Whereas it consists of again a common unit called as timing and control unit which synchronizes the operation of all four building block of central processing unit. In microcontroller, RAM and ROM are built in on the same silicon chip of central processing unit. They are very close to central processing unit and therefore they are faster. So microcontroller can implement faster RAM and ROM. Whereas since the resources are limited available, therefore RAM and ROM available with the microcontroller is lesser in size. But the microcontroller available with small to huge amount of RAM and ROM on chip. What is the function of ROM? ROM is used to store the read-only data. That is mostly the programs and system program parts. Whereas RAMs are the memory locations where you can read and write the data. So central processing unit can use the RAM to read and write the data, which is required during the execution of the program. Whereas IO ports are basically like a gate. They can provide the facility for CPU to send the data to the external world or get the data from external world inside the microcontroller system. And these ports are mostly a parallel IO port, means they can send at a time 8-bit data or 16-bit data and so on from processor to outside the microcontroller system or from outside world to inside the processor system. There are various types of ports available. Those can be digital port or analog ports. Analog port can handle the analog data from sensors also. That's why the microcontrollers are very popular, whereas analog ports are and IO digital IO ports are not normally the part of general purpose microprocessor. The microcontroller also have built-in timers. Most of the microcontroller have multiple timers for timekeeping operations and time synchronization operations required in the program. They can be 8-bit timers or 16-bit timer or 32-bit timer, or it can be a full-fledged real-time clock. Real-time clock consists of millisecond counters, seconds counter, minutes counter, hours counter, and day counter. Whereas this real time clock can be set under the program executed by CPU. A very common example is your general purpose PC system as well as your mobile phone. You can even set the date and time in your system. These real time clock, those are basically the timers. Those can supplied with the additional backup power. So when the system is made off, then also these timers are ticking and continuously maintaining the data in the timers. Those are in short the real time clocks. The microcontroller also have one to many serial ports on chip so that they can send the data serially in and out. Your Ethernet port network port is a type of serial port, or your COM port, communication port, is basically a serial port. So in general, the microcontrollers are the microprocessor or central processing unit with built-in peripherals, whereas the general purpose microprocessors are only the central processing unit and all the peripherals are implemented externally. In this block diagram, this is also the block diagram of very famous Intel 8051 microcontroller. It consists of RAM and ROM built in with 4 IO ports and 2 timers and 1 serial port with built-in central processing unit. The various microcontrollers, those are available, are listed here. Intel 8051 was a quite popular 8-bit microprocessor. Intel 8096 and 196 is another microcontroller commonly used. The microchip microcontrollers are very famous. That is the PEAK series, PEAK 16, PEAK 18 and PEAK 32 series. The ARM processor manufactured by ARM processor designed and developed by ARM systems and implemented under the license by many other companies. Those are available. Your most of the mobile phone have multi-core ARM processors. At Mega Corporation have a wide range of series of microcontrollers. One of the famous series is AVR series. ESP62066866 processor ESP8266 is a processor used for digital communication systems. Likewise, there are many companies those can provide the various microcontrollers for different applications. Microcontrollers are basically dedicated to the range of applications, particular range of applications. If you compare microprocessor and microcontrollers, the general microprocessors normally have central processing unit facility with a single chip and other peripherals like RAM, ROM, IO ports, and serial communication devices, various controllers, those can be implemented by using other chips, but on the single motherboard. Whereas in microcontroller, you will find most of the peripherals required on a single chip itself. So microcontroller systems are smaller in size compared to general purpose microcomputing system. But microcomputing systems using general purpose processors are the bigger systems. Microcontroller systems are mostly used for control application and control products from toys to automatic control operation of fuel gauging and fuel control in vehicles, temperature controllers and so on. Microcontrollers have inbuilt timer mostly, whereas general processor microprocessor doesn't have inbuilt timers. They can be implemented as separate peripheral. Whereas microcontroller have built-in IO ports and serial ports on chip. Whereas in general purpose microcomputer system, they can be implemented using additional peripheral integrated circuit like 8155 and 8255 provides the parallel IO ports. Whereas 8250 and 8251 can provide you the serial ports. These are the additional IC chips. Microcontrollers are having on-chip memory for storing programs as well as data. Whereas general purpose microcomputer system and microprocessor doesn't have this facility on chip. But computer system can implement this with the facility provided by the central processing unit. The central processing unit provides the interface, address bus, data bus, and control bus to hook up these peripherals externally. Most of the microcontroller does not support address bus and data bus and control bus signaling. So most of the microcontroller are not expandable, whereas general purpose microprocessor system are expandable. The Boolean operation, if you see the instruction set of microcontroller, the microcontroller instruction set is providing powerful bit manipulation instruction, whereas general purpose microprocessors is lacking with the bit manipulation support or having low support for manipulation of single bits. Whereas the instruction set of the microcontroller is smaller in size compared to the instruction support available with general purpose microprocessors. General purpose microprocessors are aimed for bigger computing systems where a microcontroller have focus on development of various products. Those are used for many applications. So friends, we reach to the end of this session. We will stop here. Till then, goodbye.